All right, so we're going to be looking at the ILS or LOC for the runway 4 at Greater Kankakee Airport. And specifically, we're going to be looking at the missed approach segment of this approach. And even more specifically, we're going to be talking about this hold right here. How do we get there? How we're going to be flying this hold, and so on and so forth. So when we talk about holding, right, there's three things that we need to be able to do in order to successfully execute any hold, not just this hold off of this missed approach here. And that's to, one, we need to navigate towards this point, right? If we're all the way over here, we need some way to get from here to there, right? In this case, we're going to be holding over the locale locator outer marker, essentially just an NDB. Typically, in order to navigate towards this, we would tune this into our RMI or ADF, and this RMI needle will just point towards the station, right? We don't have any specific courses we could track. We have to push and pull the needle, so on and so forth. So we have to have a way to navigate towards this fix right here. Next, we have to be able to identify the fix itself, or in this case, station passage. So we need to be able to say, okay, we are over top this point right here. In a standard VOR hold, you'll notice that it's the to from flag flip is what we're looking for that station passage. If it's a DME hold, we're seeing that exact DME measurement pop up. Um, but in this case, we want to see that RMI needle flip all the way around. Next, we need to be able to fly along and track and identify this inbound course to actually fly the hold itself. So there's three things we need to do. We need to be able to fly towards this point. We need to be able to identify this point, and we need to be able to track and identify this inbound leg right here. Um, and for this approach specifically, it specifies that we need to have ADF on board this aircraft. So like we can see in the remarks right here, it says ADF required. And that's just because ADF is what's used to typically navigate towards these compass locators or NDBs, so on and so forth. But as you know, we don't have ADF on board our aircraft. We don't have that RMI needle. We can't physically track towards these nav aids, right? A lot of other modern aircraft too aren't being installed with ADF equipment because it's heavier. We're adding stuff to the aircraft. It's more complicated systems that need to be inspected every time you go in for inspection. And the FAA allows us to do what's called GPS substitution. So instead of physically tuning our ADF, so on and so forth, we can just plug it into our GPS, and that is over here in the AIM right here. We can see right here. Operators may use a suitable RNAV system to determine aircraft position relative to a compass locator in our case, navigate to or from a VOR TACAN NDB, or again, in our case, a compass locator. So that's step one. We need to be able to navigate to that point. This AIM gives us the ability to do that using GPS. Hold over again, a compass locator right here. So we're able to, identify that station passage and identify that inbound course for this hold itself. So the AIM gives us permission to substitute this entire thing, this entire ADF required here with GPS, which is really cool. It means we don't have to have this installed on our aircraft, the super old antiquated equipment. We can just use the modern day GPS. Super nice. Now the question comes down to if I need to hold along this locale locator outer marker off of the missed approach, how am I using the GPS to track towards this point right here? How am I using the GPS to identify where this point actually is? How am I using the GPS to actually do this hold? Um, and this throws a lot of people off in my experience. When I try and do these mock stage check flights, I'll take them down to this airport and try and shoot this ILS because it's nice and close, it's uncontrolled, it's easy to get to, so on and so forth. This missed approach really throws people off. So I'm just going to kind of walk through the proper way to do this approach. So with that ADF equipment, kind of what we're going to see. And then I'll walk you through how to do it on the G1000 using only GPS and kind of compare and contrast the differences between the two. Um, as well as the similarities, and you'll kind of see what I mean when we get there. So let's go over to the simulator, and I'll show you what that's going to look like. All right, so I have loaded up here a Cessna 172 G1000 model, not unlike what you'll probably be flying. However, this one actually does have the physical ADF and DME capabilities installed in the aircraft. We're not just using GPS and substitution of it. So basically to start off, we're just going to shoot the ILS-4 approach using ADF and DME as God intended, so to speak. So we're not using GPS to substitute for it, just to show you what it's kind of supposed to look like. And then we'll kind of compare that with using GPS substitution and how the two will differ throughout it. Right, so first things first, we obviously need to tune in our localizer frequency on 108.7. That's identified with this IIKK. We can see it's tuned to that green needle there. We also have this 111.6 on nav2, identified with IKK. That's actually going to be our DME frequency. Then we have our compass locator tuned in on 272. So like I said, we actually have the capabilities to read the DME information and the ADF information straight off of the nav aids themselves, so no GPS substitution involved. So right now we're assuming we're on some sort of radar vectors to final here, and yeah, so I'll just kind of take you through the approach to see how it's supposed to look. I'm using the autopilot mode just because I'm in a simulator, but this can also be obviously hand flown as well. Alright, so our autopilot intercepted this localizer course for us, and we were able to descend down to that 1,900 feet. I also have my baro minimum set here, as well as my timer pulled up. Now this approach does require DME as well as ADF, and that's just to identify each of the fixes along the approach itself. You can see they all have a DME measurement here that we need to be, looking at. So we're just keeping an eye on that in order to identify our final approach fix, where we're going to start this timer. If we were shooting this as a localizer approach, we would use that timer to know when we're supposed to go missed. So we start that at the final approach fix, which in this case is going to be 4.4 miles out using that DME. All right, so approaching this 4.4 DME from the IKK DME station. That's how we know we're at our final approach fix. So I'm going to go ahead and start our timer. And we can also see this RMI needle start to flip around, as well as the outer marker indication start to blink and give it some, beeping noise. So like I said, that's how you know we've passed a station when using ADF, is we see that RMI needle flip around. So the compass locator was in front of us, and now it's behind us. That needle flipped 180 degrees. We've passed the station, so to speak. So we're just going to continue the approach down to minimums, and then we'll go mist and see how that looks. Alright, so approaching minimums here, it's time to go mist at our decision altitude for this approach. So power up, pitch up, clean up, report the mist to ATC, so on and so forth. Now for this mist, we're going to climb up to 2,300 and then make a right turn direct to the locale locator outer marker, and then we're going to hold there. So this is why we need to be able to identify how we're going to fly towards this locale fix, because there's no VOR courses or anything that we need to track to get there. It's just, make this right turn until you're flying directly towards the point. Alright, so we've made it up to 2,300 and we've started that right turn towards the station, towards the locale locator outer marker. So we basically just have to follow this blue RMI needle. If you remember, the way the RMI works is, so long as we have a station tuned, we just fly towards it, and that blue needle is going to point towards it whether we like it or not. So makes it nice and easy in order to go directly to the station. Now it's important that, like VORs and like courses, this is based on your ground position, not necessarily your heading. So we do have to account for winds. If you're in the S model with the G1000, like we are here, all you have to do is place that magenta diamond right on top of that RMI needle, right at the head of that arrow, and it should take you directly towards that station. All right, so localizer needle is starting to come in here. That outer marker is starting to identify again, and so you can see that RMI needle is once again starting to flip around as we pass over the station. Now we could theoretically use just the RMI needle to hold along a compass locator or an NDB, but because in this case the holding course is the same as the localizer course, um, just make your life easy and use the localizer, right? So this is going to be a parallel entry. I've started my timer for that 1 minute outbound, and we'll see what it looks like when we actually enter the hold after the entry. All right, so as we approach this holding fix again, this locale locator outer marker, we can once again see that flashing O start to illuminate, meaning we're getting close, as well as again that RMI needle flipping around. So again, that RMI needle flipping around is what constitutes station passage and when we start this outbound turn for our hold. So we'll just go ahead and start that. We'll start that outbound turn and then start the timer once we're beaming. So as you can see, it's actually really simple, right? All we have to do is set us up. We tune that DME frequency, we tune that ADF frequency, or the compass locator in this case, and we just follow what it says essentially. With the GPS, though, it gets a little bit more complicated because we don't have the equipment on board. We have to use something else. So let's go ahead and take a look at what that might look like instead. Alright, so we're loaded up in the same place as we were before, 2,500 feet, getting radar vectored onto the final approach course. We've got this 108.7 tuned in at the top here. That's going to be IIKK, our localizer and glide slope frequencies. But obviously we can't tune our DME or ADF frequencies because we don't have that equipment on board. So we're going to have to use GPS instead. I'll start by putting in a direct course to IKK. That's going to be the DME station for this approach. Sometimes approaches have DME stations co-located on the ILS or the localizer frequency. In this case, it's kind of a standalone station, so you kind of have to pay attention to where you're getting your DME information from. You can see at the top it's identifying IKK. We're about 18 or so miles out. Another thing we can do is if you go to PFD options and then click on bearing 1, just keep clicking on that until eventually you get to GPS, and eventually it'll show the distance information at the bottom as well. It'll also pop up with this blue RMI needle. Now that'll come in handy later when we start tracking towards that compass locator, but for now we're just looking at that distance information. Next, if we go to the flight plan and go to the en route section right here, what I like to do is use this en route thing as kind of a standby GPS. So loading up any waypoints we need to use later in the approach, just preemptively. So in that case, we're going to be using our locale locator outer marker as a GPS waypoint as well after we're done with the DME. So go ahead and load that into the en route flight plan section. Now the problem with doing this is that it will want to sequence the waypoints. So as we pass over that DME station, it'll automatically go to locale. And then as we get to the locale, it'll automatically go direct to the airport, KIKK, our destination. So what we want to do is click this OBS button at the bottom here. And what that'll do, that stands for Omni Bearing Selector. It basically allows you to use your GPS as a VOR indicator, essentially. We're allowed to tune in specific courses to and from specific GPS waypoints, in this case our DME station. But what it also does, and what's important for this, is that it prevents sequencing this flight plan. So instead of going to locale and then going to IKK as we pass over those GPS waypoints, it'll hold those in the GPS as the active waypoint until we put in a next direct course and we say, okay, no more OBS mode. So another way of setting up our GPS for this approach is to load the GPS overlay. So if we hit the procedures knob, type in KIKK, and select the ILS, it'll load all of these DME fixes as individual waypoints. So instead of monitoring a single DME station and getting the distance information from that, it'll load the waypoints themselves. Now again, this is completely allowed by the AIM, so long as we're monitoring that primary navigate, that localizer, ILS, and such. But the thing about this is, well, there's that, but if you see here, all of the waypoints that it loaded, Now this is like the bare minimum that we need to shoot the ILS. All of the ones that we need are there, like Seaweed, High Rails, a final approach fix, and then IK or Lookout, that missed approach holding point. Um, they're all there, but you'll notice that there's a couple waypoints that are missing, like Zihi and IKK, the VDP, um, at 1.3 DME are not there. So if we wanted to shoot the localizer approach instead, um, the waypoints we need would not be there. Or if we had to revert back to the localizer in case our glide slope failed, we would not be able to do that. So just keep that in mind, and that's why I prefer to just load up the DME station. That way we can identify each of the points without having to rely on that GPS overlay. Alright, so now we're approaching that 4.4 DME fix at high roll, our final approach fix, as well as our glide slope intercept, as well as our outer marker. You'll notice that the RMI needle is not going to flip around, and that's just because we're monitoring the actual DME station, and not, we don't have that RMI tuned to that compass locator. So RMI is still pointing directly towards that DME station. We're still getting DME information from our GPS, but we'll only monitor that compass locator once we go missed, as you'll see here in a second. Okay, so coming up on minimums, let's go ahead and go miss, power up, pitch up, clean up, contact the ATC, tell them we're going missed. And we'll go ahead and get that missed approach set up. So we're going to climb to that 2,300 feet and then make that right turn. We'll go ahead and put direct to Lookout into our GPS. So we already have that in our flight plan, just direct enter it. And there you go, that RMI needle is now starting to point to Lookout. Now once again, we want to hold that OBS mode active, just because once we get to Lookout, we don't want that sequencing towards the next waypoint. You can see it's not all that different from going missed off the ADF, it's just switching it over. The biggest thing is obviously don't forget to push that OBS button. We don't want the flight plan automatically sequencing when we want specific information from that point to do our hold and such, and you'll see here in a second. Alright, so as you can see, we got that blue RMI needle pointing directly towards Lookout. We got that plugged into our GPS. And you can see we're navigating towards Lookout. We're about 5 miles out. So we're not using GME information from that station anymore. We're now getting distance information directly towards the point itself. Now, what we can do also is to, again, use that OBS mode, allows us to tune specific courses. So if we want, we can do the hold entirely off of GPS. So if we flip around our course, using OBS mode to the localizer course, that 42 degrees, we can do that just fine, and then keep everything on the GPS. We're tracking the magenta line, we're tracking towards a magenta waypoint, so on and so forth. The only thing here is that the sensitivity with the GPS is listed as terminal, as you can see. Now that means a full deflection one way or the other is going to be 1 whole nautical mile, meaning that this needle is not going to be very sensitive. So personally, I like to keep it just keep the CDI needle tuned to the localizer course, that green needle. That way we're getting a much more sensitive and accurate reading. Though you could do either one, it's really up to you. Right, now approaching Lookout, we'll start to see this distance going down. We're at 0.5 miles away. That blue RMI needle is going to want to start flipping around as we pass that waypoint. And of course that localizer course is going to start coming in, as well as the outer marker is going to start beeping again. So we have a lot of different ways to know that we're at Lookout. It's just getting there, we're using GPS. So from there I'm going to do this parallel entry, and then I'll show you what it's going to look like on the way in. And after proceeding through the parallel entry and coming back towards Lookout on the inbound leg, we can see that our distances start to close. We're at 0.4 miles out now. The outer marker is starting to go out, as well as this blue RMI needle is going to want to start flipping around. Now again, because we have OBS mode enabled, it's not going to sequence the next waypoint in the flight plan. So it's just going to continue navigating us towards Lookout, getting us distance information for that. And yeah, it's not going to mess our hold up or anything like that. Just like that, we have entered the hold at Lookout off the missed approach. So as you can see, as long as you set everything up properly and do it before the approach actually starts, there's really not that much to do. It's just setting up for it is the hard part. And hopefully that clarifies a little bit for you. As always, let me know if you have any questions or clarifications. Yeah, see you later.